In this problem, I'll again talk about a projectile which is launched from a height at an angle theta towards the ground. So for example, here we have a projectile or a ball, and when launching this projectile at an angle theta in the downward direction. And now again we need to find out how long the ball remains in the air. We need to find the horizontal distance, this horizontal distance, at what angle it hits the ground, what are the components of the velocities when it hits the ground. So let's do it. So this is the angle given, and the initial velocity is 10 meters per second, this velocity, and the height is 2 meters. So once we know this initial velocity and this angle theta, then we should be able to find out the horizontal and the vertical components. The horizontal component would be simply equal to V0 cosine theta, and the vertical component would be V0 sine theta. So the horizontal component is now V0 cosine theta, and the V0, which is the initial launch velocity, is 10 and angle is 45 degree. So you plug in, you'll get 7.07. Similarly, you'll get the vertical velocity, which is V0 sine theta. It will be 7.07 meter per second. Now let's find out the time of flight. What does this mean, the time of flight? The time it remains in the air, or the time it takes to reach to the ground from this point. When you launch it, when you throw the projectile, how long does it take to reach to the ground is the time of flight. So we now just taking the two independent equations, the one along the x-axis and one along the x-axis. So for time of flight, we're going to calculate by using the equation along the y-axis. So this is the equation, and remember here we have chosen this as in our origin, this as in our x-axis, and this is our y-axis, the downward, just for convenience. You may choose any way you like to, but remember, when you choose in a different way, you should be able to write down the velocity and other the variables with the proper sign. So y is the final height, y0 is the initial height, v0y is the initial velocity, t is the time, half g is the acceleration due to gravity, and t is again the time. So when we have chosen this as an origin, then the final height would be 2 meters, because the particle is now moving in the downward direction. So this is our final height, 2 meters, and the initial height, which is at this point, will be 0. The initial vertical velocity is 7.07, and we need to find out the time. Half g is 9.8 t square. So this is now a quadratic equation. So if we just simplify this one, it will be a quadratic equation. I think I made a mistake here.